So I'm going to talk about two things tonight. Something that happened quite recently was the landing of the Philae lander on Comet Churyumov-Gerasimenko after leaving the mothership Rosetta. I'll talk about that last. I think it's probably the greatest achievement that European space science has had. But exactly 10 years ago, actually 10 years ago, not exactly, almost precisely, but 10 years ago minus exactly 1 week, we landed on a moon of Saturn, Titan, 10 times further from the sun than the Earth, and twice as far from the sun as the landing of Philae. And I'm going to talk about that too. They're both immensely significant to me, but they're also very significant for European space science. They really marked Europe growing up and standing on its own in major achievements on the final frontier. So how did it all begin? It actually began in the late 70s when really there was something that even European astronomers couldn't ignore: the return of Comet Halley. Comet Halley is a once-in-a-lifetime event and returns every 75, 76 years. So there are people who see it twice, but not very many. And Halley, well, he wasn't exactly European, he was British, but there was this sense that somehow Europe ought to do something. And so up to that point, there had almost been an edict that Europe didn't do planetary science. If you wanted to do planetary science, you went to the United States. I guess there was always also the Soviet Union you could go to. The French used to go that way sometimes. But really, you had to go to the US. However, it was decided to do something originally, needless to say, with the Americans, to go to Comet Halley. The Americans are wonderful people, but they suffer a little from believing their own hubris. And what happened then was, although they wanted to go to Comet Halley, they couldn't afford to. And Europe was forced to stand on its own feet, if that's something that Europe could do. And in 1980, they patched together the idea of going to Comet Halley with a spacecraft that they named wonderfully Giotto, because, of course, Giotto had painted Halley's comet, or painted a comet. People tend to attribute it to Halley. And what they did was take a spacecraft they'd built once for looking at the Earth's environment and converted it. They put a big shield on it so it might survive in a cometary environment. In fact, that was a major success in every country in Europe except Britain. Here, we got the public relations wrong. I think in every other country, it was really quite an invigorating step for European space science. Somehow we didn't get it right here, which I think was bad management of communications. I think the European Space Agency has improved a small bit. Okay, so in fact, the two things I'm going to talk about today originated before we'd got to Philae. 30 years ago, a group of American and European scientists met far away in California to look at what might be done to explore jointly the solar system, particularly small bodies and outer planets. At the time, Europe had no plans to explore the solar system at all. That was Terra Americana. And many wanted to keep it that way. Many astronomers did. Nonetheless, something happened and the result was successful. And Europe and the US, I'm happy to say, and I'm going to tell you about tonight, two parts of the final frontier you can regard as European. In fact, I was invited to go to that meeting in California. I can give you the date, 30th of June, 1982. It was at JPL in California, in Pasadena. And my approval to travel was vetoed by the by what was the Research Council at the time. And I was told by a very embarrassed, rather junior person, it came from the very top, from the head of the Research Council. Not approved, because we don't want to get involved in exploring the solar system. It's expensive. It'll cost money. In fact, that's changed. It's now cheaper to explore the solar system than to build really big astronomical telescopes. That's a big change in the last 30-odd years. Anyhow, I had American friends, and as a result, got to JPL in California, took part as a European in the planning of the first mission I'm going to talk about. 30th of June, 1982. There are people here who know why that's significant. Yes, it's my birthday. Since my brother's in the room, I think he probably had worked that out, and I think my wife probably remembered. So the first thing, which really, when I came back and wrote a report, because I thought even if the UK hadn't paid for me to go, I would at least send in a report on the meeting. I described this amazing idea that we should go to Saturn with the Americans and we should build something to land on Titan. The state of planetary science in the UK at that time, there was no planetary science group at Cambridge. I think that was what was wrong, was that why not go to Saturn? And of course, that misses the point. What's special about going to Titan? I'm going to tell you. What came out of that, it was called SOT-P at first, Saturn Orbiter Titan Probe. Cassini-Huygens was the name it adopted in the end, with the mothership built by the Americans called Cassini, named after a Franco-Italian astronomer, Cassini, and then the lander to land on Titan, a moon of Saturn, was called Huygens, or if you pronounce it in Dutch as it should be, it's some sort of coughing sound. As they say, Dutch is more of a throat disease than a language. Anyhow, listen, if I mastered Huygens, you can imagine how easy it was to learn Churyumov-Gerasimenko. Okay, the Saturn System. It's a wonderful place, and you'll find I've an enormous love of the Saturnian system. It's almost like a solar system within our solar system. In fact, it's hard to be certain about the number of moons of Saturn, because the number increases because we keep discovering them. I think we're up to 62. And I always say that with some doubt, because there's generally somebody in the audience who noticed that another one has been added. I think we're 62 moons. And of course, if you ever have looked through a telescope, I hope that you looked at Saturn. It's the most amazing sight. It has these rings. Other planets, Uranus and Jupiter, have rings. Nothing as spectacular as Saturn. In fact, there's an enormous amount of dust there also, and in fact, there are dust rings that you can't see through a regular telescope. In a way, what you have, those dust rings and the rings themselves, are part of understanding how our solar system came to be. They are forming things like moons, which of course on the solar system level are like forming planets around the central star. So why Titan? Well, Saturn itself, the planet, is not unlike Jupiter. It's a gas giant. It probably doesn't have a solid surface. The gas pressure just gets bigger and bigger. And in fact, at the end of the Cassini mission, we will send Cassini down into the clouds, and it will die being crushed by the pressure of that atmosphere. However, what is unique about Saturn is, apart from its rings, other planets have rings, other planets have moons. But no other planet has a moon with an atmosphere. Titan has an atmosphere. It's made of nitrogen, just like the atmosphere in this room. I mean, I know there's a bit of oxygen in this atmosphere too, but it's getting less and less as the meeting goes on. But the nitrogen doesn't interact, it's just there. In fact, what's missing, we have in the atmosphere hydrogen, nitrogen, and carbon, and rather nasty chemicals made up from hydrogen, nitrogen, and carbon. But there's no oxygen. In fact, there is lots of oxygen at Titan inside the moon itself. The moon is largely made of water ice. So there's plenty inside water, there's plenty of oxygen. It has to be released. It's so cold. The temperature is around the temperature at which methane becomes solid. So when methane freezes. Now, do you know what's special about our own planet? When you look at it from the outside, you think, what's very interesting about the Earth as opposed to Venus or Mercury or Saturn is the surface temperature. It's at the right position relative to the sun. The surface temperature is at the point where water can be solid, liquid, or gaseous. You've noticed it's been liquid today. Certain parts of the country, I'm sure that it's solid, and of course there's plenty of water vapor in our atmosphere. The temperature, surface temperature of Titan, the equilibrium temperature for where it is in our solar system, is such that methane has exactly that same property. It's at what is called its triple point, and methane can be solid, liquid, or gaseous. Now, you probably don't think about the fact that water can be in one of three phases at the surface of the Earth is incredibly important to making the Earth function as a place for us to live, because it drives meteorology. All the energy that pumps the air around is due to water changing phase and coming down from time to time as rain and then coming out of the sea and keeping a weather system going. We predicted that methane would be the agent of meteorology at Titan. The funny thing was, we couldn't really see down into the atmosphere of Titan because of all the nasty compounds of carbon, hydrogen, and nitrogen. It's a bit like the atmosphere above Los Angeles in the old days, a sort of brown, orangey color. And of course, it was very nice that it was in fact discovered by a Dutchman, Christian Huygens, because as you possibly know, those of you who are interested in international football will know, the Dutch color is orange. And this, indeed, one of the nice things about landing on the orange moon of Saturn was I got to meet the Dutch Queen afterwards, because she regarded it as Dutch territory. Okay. Why is that so fascinating? Well, I hope it's interesting already. What's particularly interesting, for the first billion years of the Earth's life, our Earth had an atmosphere almost identical to that of Titan. So going to Titan is a trip back to the beginning of our own planet. There is a complex chemistry going on and a meteorology, moving things around, cooking things. Eventually, oxygen will leach out of the planet, out of the moon, and we'll have a proper atmosphere like we have at Earth. You've got to wait about 1 billion years for the sun to turn into a red giant. At that time, life on Titan will become really quite rosy. Life on Earth will become even rosier, because a red giant, as the sun becomes a red giant, I'm afraid that's the end of Earth. So book your great-great-great-great-great-great-grandchildren's tickets to leave for Titan before 1 billion years are out. Okay, well, we started work on planning how we would persuade the American Space Agency and the European Space Agency to come together to do this magnificent mission, this idea we had. And it was very important for us Europeans that we did the lander on Titan. I'm afraid you don't do space science simply for the joy of exploring. You also have to tell the taxpayers that they're getting something back in return. And there were all sorts of fascinating technologies that the Americans already had that you could test out and demonstrate if you could demonstrate that you could land successfully on a moon of Saturn in an atmosphere whose pressure is actually about the same, it's about 50% higher than the pressure in this room at this moment. 1.5 bars. Pressure in this room is around 1,000 millibars, or 1 bar. Okay, well, it took about best part of 10 years to persuade ESA and NASA that they should do it. But around 1989, they finally committed. Don't worry if you don't have to read all this. It's really just to give you an impression that this took a long time. The mission began around 1982, the idea of the mission. It now will finish when we plunge Cassini into the atmosphere of Saturn in late 2017. That is over 35 years, this mission. Okay, well, it's half a lifetime for me. Obviously much more than half a lifetime for some of you. There you go.
15 seconds.
Interestingly,
T-10.
when you actually have
9,
got the
8,
thing built, what
7,
do?
6,
You put
5,
your spacecraft
4,
and your instruments
3,
on
2,
top of a lot of
1,
high explosive.
And liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
I still get a joy out of watching this. This is a Titan 4B, a very, very big American rocket, taking off in the early morning. And at that point, I stopped the movie because if you can arrange to go to a launch where there is cloud cover, partial cloud cover, do so. It's terrific. As the plume goes through the clouds, the whole sky lights up. It's almost like as exciting as an eclipse, that change. Night launches, I just love them. Okay, so there was the launch. That was in October 1997. 7 years later, on the 30th of June 2004, anything significant about? Okay. We arrived at Saturn. By that time, actually, at the time of the launch, I had just finished being head of department at Imperial, head of physics, and I moved to the European Space Agency. So I've been 7 years away from Imperial when this point came. This was a hairy process getting into orbit. What you can hear there is dust hitting the spacecraft antenna as the spacecraft goes through closest approach to Saturn we ever had.
Here's the outgoing ring plane crossing.
Twice we had to cross the rings and go through the ring plane. And of course you can hear that noise. We picked up that noise, of course, considerably after we had passed through the event had taken place. That was nail-biting. In fact, what happens afterwards, you know, Americans are very emotional people. And this was an American success. They put the spacecraft into orbit around Saturn and actually been inside the rings of Saturn and crossed the ring plane successfully. Everything was working. What do Americans do? They do this thing of high fives. You know, I mean, me and an Englishman, my tendency, oh, jolly good show. But you see, if you look in the back behind the flight director, Julie Webster, you can see some gray hair there and somebody doing a high five. Shame on me, going native. And that's with the head of the Jet Propulsion Laboratory, who in charge of the mothership. I was in charge of the lander. So I got a few months rest then until October, when after 3 orbits around Saturn, we had to land Huygens. And remember, this is what we promised to do many years before, 15 years before probably. And Americans talk about the 8 minutes of terror when something lands on Mars, because you go through a period where you have no communications. Huygens left the mothership, Cassini, 3 weeks before it landed on Titan. And I assure you, you don't have 3 weeks of terror. You don't have 3 weeks of boredom either. You have 3 weeks of sleepless nights. In fact, I really still wake up and remember it did land successfully. I mean, and if you wonder why I was so nervous, 1 year before, in fact, precisely 1 year before, the separation of Huygens from Cassini was on Christmas Day, 2004. It landed on the 15th of January, 3 weeks later. Anyone remember what happened on Christmas Day 2003? Yes, the loss of Beagle 2. Beagle 2 was the British lander built to go to Mars. And what gave the British the confidence to take on a planet that had a dreadful reputation for failures, a disaster, a sort of Bermuda Triangle of a planet. We lost Beagle on Christmas Day 2003. The confidence to do that was based on the fact that the British got lots of work building Huygens. But remember, Huygens was built in 1997. That's 4 years, 3 or 4 years before the launch was 3 or 4 years before anyone started building Beagle. So the technical work on Beagle, on Huygens, was before that. But the skills were there, and however, in Europe, I mean, Americans are much better at failing than we Europeans. And I think it's an insecurity we have that is rather foolish. If you're going to explore, you can get things wrong. You know, we're proud of our explorers who got things wrong. Captain Scott, for example. Somehow in space, we have to get it right every time. Beagle, in my view, was actually a major triumph because it got to Mars. That was an achievement in itself. Huygens was an even bigger achievement because it got to Titan and worked. Now, it was a complex entry, and I'm not going to tell you too much about it, simply because I don't have the time. The little baby was spinning around as it came down, and I'm going to disentangle all of the rotation and so on and show you what it would have looked like if it hadn't been spinning. January the 14th, 2005.
January 14th, 2005 begins with the Earth passing directly in between the Sun and Saturn, an opposition so perfect that it occurs maybe twice per millennium. Meanwhile, the Huygens probe, quietly entering the Saturnian system, is about to end its 7-year journey. As Huygens approaches, the inner planets cluster around the distant Sun. Saturn appears almost as large as Orion. A few moons are visible as white dots aligned with Saturn's rings, while Titan, its largest moon, is already well resolved. Huygens is destined for Titan, a mysterious world larger than the planet Mercury and shrouded by a thick brownish-orange atmosphere.
Very clearly.
The details of its surface
From now
have
on,
never been seen.
The
Huygens speed
images
increases to near
are
6 kilometers per
reconstructed
second.
from the
Titan's
imager
disk quickly obscures
on
our
the
view of Saturn
descending
and its more
probe,
intimate moons.
Huygens.
As the probe enters Titan's
pretty
atmosphere, the heat shield reduces the speed some 15-fold within a few minutes.
We're about 120
the
kilometers above the
speed
surface at
further.
this point.
15 minutes later, the smaller
there,
stabilizer chute
75
allows a
kilometers,
faster descent at
we
first,
start
but slows
seeing
as Huygens enters
what
the
we've
lower,
never been able
denser
to see
part
below
of
the
Titan's
smog
atmosphere.
of the atmosphere,
Huygens is approaching a dark
landscape
valley between
of
brighter hilly regions.
Titan.
Beyond the hills to the left, two
And you
dark
could
parallel
immediately
lines
see
appear, which are later discovered to be
rivers.
part of a vast system
We
of dunes.
promised
which
there
surround
would be
the moon.
rivers of methane.
At 21 kilometers altitude,
I can't tell you
the
what a
probe
shock it
moves
is
through
to a
thin
scientist
haze
to
layer
find out they've
as
made
seen on the
a
horizon.
prediction that turns out to be
The
true.
bright area near the center top is the glow of Titan's haze illuminated by the sun. A complicated system of drainage channels, some hundreds of meters wide and kilometers long, are seen cut into the hillside. These are probably the result of runoff from methane rain. Stereographic imagery reveals hills to the left to be perhaps a few hundred meters tall, while features in the valley are tens of meters in height. For most of the descent, the probe travels eastward above Titan's surface. However, below 7 kilometers altitude, the motion reverses into a backward westward motion. It reverses again at 1 kilometer altitude, and we move slowly southeastward. Hang on, as Huygens lands on Titan's surface near a water ice outcropping ridge.
The music
Another
was added
westward-looking
afterwards.
view of the descent from 31 kilometers shows the area of Titan over which the probe has just flown. This affords us a good view of the drainage channels and apparent shoreline. More dark lowlands appear and a rough pitted hillside to the left. Spectra of the surface suggest that the bright areas are water ice, and the darker areas are a type of hydrocarbon mixture that has never been produced in the laboratory. The small white dot in the lower center part of scene tracks our progress over Titan's surface. We see the reversal in direction at 7 kilometers altitude, and we fly over the ridge near where we will land. As we approach the surface, our perspective brings the topography to life. We see that although there are rivers and a shoreline, the basin is dry. Below, there are distinct signs of erosion which crafted the rugged ridgeline. Huygens sinks into one of these gullies. We experience a relatively soft landing on Titan's surface. The view from the surface reveals an amazingly Earth-like picture of a dry riverbed, with distant hills which are a few meters in height.
Parachute shadow.
Some seconds after impact, the shadow of Huygens' parachute drifts across the scene.
So actually we didn't see it in color. The first images we got were like that, black and white. You can see that dendritic structure of channels, as he said. Well, they're rivers. They really, for me, that was a magical moment. There really had to be a meteorology based on methane on this object. And this sort of coastline, as he mentioned, in fact, now we've discovered lakes of methane over the surface of Titan from the mothership. In fact, this was the first image taken once we were down and landed. And you'll see there's a crack in this boulder here. These boulders are actually primarily water ice, but water ice at minus 179 Celsius. They are rock hard. It's very likely that the surface science package of Huygens hit that and cracked it. And the person in charge of that is a Briton called John Zarnecki. And I'll come to him in a minute. But he had not filed an environmental impact statement. But he's at the Open University, so what do you expect? Okay, how did it feel? Well, actually, that's one of the happiest pictures of me I think I've seen. And this is talking to an Imperial College physics graduate, Palab Ghosh, who some of you may know, BBC science correspondent. There is John. Don't bother about reading the story. I'm going to tell it to you. John, really, I thought he was crazy. He built the surface science package for this lander. There was no guarantee he would get any data back at all. He had to design an instrument that could also handle the fact that we might have landed in a lake or in a sea. Think of sending something down onto the surface of the Earth without knowing where you were going. The odds are, at Earth, 2 to 1, you'd land on liquid. So Huygens was designed to float. Whether John's instrument would have handled floating, I don't know. I thought he was crazy, but he did it, and of course became the first person, in a sense, to touch Titan, and in fact probably do some damage. John and I both are sort of similar age, went to grammar school, as people did in the 1950s, and not very good at expressing our feelings. This event was an emotional experience that Englishmen shouldn't have to go through, really. And we stood around outside because we knew we were going to have a press conference and there'd be Americans there. And Americans sort of, you know, they don't have the English language precisely. And that makes, when they're very excited, makes them rather charming as they sort of use words like wow and so on with a level of emotion that seems to be real. And John and I said, well, what, we can't deal with that. Doing a high five is enough. So we sort of thought, what do we have over the Americans, apart from the English language? And we said, well, of course, it is the English language. What did we learn at school? And of course, one of the unpleasant things of going to a grammar school in the 1950s was having to learn poetry. And we thought, poetry. Americans probably can't spell it. So you go out, we said, well, what poem would do? And we could remember something about staring with a wild surmise. I couldn't remember the rest of the poem. I knew it was something about crossing the Panama Isthmus, but I couldn't remember wild surmise. Well, if you Google wild surmise, you get the poem. It's actually by somebody called John Keats. I didn't bother to look up who wrote it, because I knew Percy by Shelley. I can tell you, if you say on television, this poem by Percy by Shelley comes to mind, and repeat these words, you get a lot of emails. So then, and this, I don't know, it actually did absolutely suit the purpose of expressing our emotion. Then felt I like some watcher of the skies, when a new planet swims into his ken, or like stout Cortez when, with eagle eyes, he stared at the Pacific, and all his men looked at each other with a wild surmise, silent upon a peak in Darien. There you are, Percy by Shelley. It sounds like Shelley. No, it's John Keats. Bear that in mind. And Romantic period, of course, wonderful. If you understood those words, you understood how we felt. And that painting by Caspar David Friedrich also has this sense of being on top, looking at a totally unknown land in front of you. And the fog was very appropriate at Titan. So we got images for much longer than we expected, and we got the radio tone on the Earth by using radio astronomy telescopes right across the globe to pick up a signal about as strong as that from your mobile telephone, coming from 10 times further from the sun than we are. I mean, that's an extraordinary technical achievement, magnificent signal processing, and something that I found absolutely, technically, I just loved it. Well, John had, being British, actually got to meet this man who you probably remember. He was a prime minister, I think. I, of course, being French at the time, I got to meet the President of France, along with, of course, later the Queen of Holland and so on. President of France with the lady there is not my wife, it's the head of the company that built Huygens, Pascal Souris, she's called. And there, I was very impressed. I'd never met a president. Well, of course, I became president of the Royal Astronomical Society, but I'd never had a real president before. I was very impressed. He then did, to the television cameras, outside the Élysée Palace, you can see him talking there, he did an impromptu speech for 10 minutes until he realized that the television camera people were running to get it onto the news, and so were no longer filming him. But he spoke without notes, and clearly he'd picked up, we'd of course been talking to him for about an hour, and he'd picked up what we were doing, and he did it brilliantly. I was very impressed. Until that point, I'd not had a high opinion of President Chirac. But it was an extraordinary performance, and interestingly, he gave a speech in Barcelona the next day, which was entirely about Huygens and totally unscripted again, because the Elysee Palace site had to scramble to put up the speech he used in Barcelona on science and technology, but he decided to talk about Huygens. Impressive. And he corrected my French, which is sort of something you can say. The President of France has straightened me out on how to pronounce kilomètre and things like that. And he said, "Thank you for having made me dream." And I half believed it. I am a sucker. Okay, so there we are, Huygens. It's in fact, even after Philae, still the most distant standing artifact of human civilization on a body that 1 billion years from now will be better for sustaining life like us than our own planet will be then. So you can imagine the little green men, Rod, coming out and banging on the side, trying to work out. This is the only piece of our civilization they'll have. And it's European, in fact. Some of it is British. At the moment, it's very dark out there. I should emphasize this was a program with a lot of Britons, and here are 3 of the key Britons. John, I've mentioned. Hamid Hassan was the project manager, who sadly died before we got to Titan, and George Schoon was the study manager. And in fact, the project team had something that happens in international organizations. People of a given nationality seem to nucleate, and there were rather a large number of Britons in the project team. Many British companies involved. So what about an encore? And of course, you know what the encore is. This idea of going to a comet after Halley was seeded at the same time as Cassini and Huygens, and again was originally to have been joint with the Americans.
It was a picture
This is not
for this
an American
unique
launch.
profile mission involving a long ballistic phase and a delayed ignition of the rocket's upper stage.
So there you
2
are.
hours after liftoff, Rosetta
Another
left
nice
Earth behind,
cloud-covered
heading for the
night
outer solar system.
that lit up.
In the Jupiter control room in Kourou,
There's the chap who did the launching. See what he has to say. He was supposed to say something. Come on.
Yet another mission in space.
And you'll see,
Rosetta and its
I'm
lander
very,
Philae
very
are now
happy.
off on their 10-year mission.
In fact, Rosetta was the most difficult project I had to manage on the ground. The launch was delayed by a year. It cost me an extra 70 million euros. And amazingly enough, although I had a substantial budget, it wasn't one where I had 70 millions in my back pocket. And I had to find them all in 12 months. There were all sorts of political wrangling, fighting, because I think everybody knew it was going to be a great thing. And so everybody wants to be in charge. Everybody wants the glory. That sense of having finally got it off Earth, you can see in my face in that short clip. So, the comet itself turned out to be something else. I mean, if I'd known this is what the comet looked like, I can tell you we would not be there now. I promise you, if I had any clue, of course, having got there, one feels wonderful about it. It is an extraordinary looking object. And it is unlike any other comet we've seen, and to land on this is certainly an enormous challenge. I mean, You can't rely on gravity to just point down. You know, the mass is not distributed uniformly on this thing. We let our little baby go. There she goes. There's Philae leaving the mothership. At the same time, you understand it's going into an unknown environment. We'd no idea what would be the surface. You know, how dusty it would be, whether you could grab onto it, whether it would simply sink into a meter or so of dust. That was entirely possible. In fact, the comet was already active. This is an enhanced view to show material blowing out from the comet. This is going, the output of the comet will go up by a factor of 10,000 from the state it was in then. And indeed, that's of course the exciting thing. Rosetta is going to be sitting close to this body as it goes into a cometary display. We're going to do a lot of science in the coming months. In fact, science has started. You probably know that something rather major has been discovered already. It has the wrong sort of water. It's a bit like southern region having the wrong sort of leaves. You think, you're going to a comet. There must be water there, but in fact, the deuterium to hydrogen ratio is radically different. That's important in terms of where the water on the Earth came from. Up till now, we'd assumed, or we thought, a lot came from comets. Well, not from this comet. It's got the wrong fingerprint for its water. This noise you're listening to is also a mystery. It's actually from a speeded up signal from the magnetometer, which actually I build magnetometers. That's how I became famous originally. From the mothership going around the comet, you can hear this endless music of the comet. We don't understand what it is, and indeed that's rather nice. We'll work it out. We're going to watch this comet. And there is something rather hallucinatory, in my view, about the sound. Okay, I didn't meet the French president, but my French colleagues did. Here we see the head of the French Space Agency, Jean-Yves Le Gall, Valérie Pécresse, the Minister for Science in France, President Hollande, and Michel Rocard, who is head of the French Space Agency Planetary Exploration Program. This is a day on which I don't feel like making fun of the French somehow, which is what, if I were giving this talk at another time, I would now start doing. So you'll just have to guess what I might have said. But what you can do if your president is devoted enough to come along to such a thing, you can get him to wear funny glasses and play him funny noises. And he's still sinking in the opinion polls. But there you are, President Hollande and Jean-Yves Le Gall looking at 3D imagery. I was in Germany for the landing event. It was a worldwide response from the press. This is just the newspaper that I picked up from the hotel. I don't quite know why it's the Stuttgart newspaper when I was in Darmstadt, but there you go. And Spektakuläre Landung. And what I liked particularly is Mini-Labor Philae erreicht Chury. And that's, for those of you who don't speak German, that is miniature laboratory Philae grabs Churyumov-Gerasimenko. You see how easy it is to say Churyumov-Gerasimenko in German. A lot easier than in of course, I did my little bit of getting Rosetta off the planet, but there is one thing I'm particularly fond of as I close here. Rosetta is named after the Rosetta Stone. And the idea was, if you go to a comet, if you sketch it and sniff it, you are looking at the primordial material from which the solar system was made, from which planets were made, from which moons are made, from, indeed, even our sun. So it was a Rosetta Stone in decoding history. But you know that the Rosetta Stone was critical in teaching us how to read hieroglyphics. It didn't teach us how to pronounce hieroglyphics. It taught us how to read hieroglyphics, discovered by Napoleon's soldiers and rather generously given to the British Museum. I hope we're all grateful. Well, Rosetta, when I was Director of Science, we got approached by the Long Now Foundation in California, and they wanted to know if we would put a small disk on the spacecraft, because the spacecraft after the mission will go on orbiting the sun forever. And so when the aliens finally arrive, one of the first man-made things, human-made things they'll come across is Rosetta. So we should give them a Rosetta Stone to decode our languages. Rosetta Stone here, this disk, it's 7.6 centimeters in diameter, has the Genesis story, the first book of the Bible, which is Holy Writ to Mohammedans, Jews, and Christians. I thought that would be enough, but in fact I got complaints about the Hindus and Buddhists believing the earth started in a different manner. But anyhow, I thought that was a wonderful thing, that take the first book of the Bible for 3 different major religions in 1,000 languages. And it's not stored in any digital form. It's actually micro-etched, so you will be able to read it. Whoever finds it will be able to read it by simply magnifying and magnifying the micro-etching. And you will get Genesis story 1,000 times in 1,000 different languages. Okay, well, my staff, some of my staff thought this is nonsense. California, they've been smoking something they shouldn't. Who are these people? Well, here was the little thing. It looked great to me. I started off life as a linguist, so it had an appeal anyhow. But then I found out that associated with the Long Now Foundation was somebody that I don't know if anyone recognizes. I think my brother should recognize this person. This is Brian Eno, very famous musician and artist, very interesting man, and greatly admired by my 2 sons, who were interested in composing music using computers and things like that. Brian Eno initiated that kind of thing about 30 years ago, as some of you will know, 40 years ago. And I thought, this could impress my sons. I thought, I say, well, we're doing something for Brian Eno. Wow, Dad, caw, what's that? That's impressive. My sons speak like Americans. But anyhow, so that's what we did. We put the disc on, and it's there, a true Rosetta Stone for our civilization, going out courtesy of the Long Now Foundation of California. So there you are. This is a sentinel for our civilization. It'll just go on orbiting the sun for time immemorial, and on it will be this little disk. I do hope the little green men find it. So there's a farewell view. This is a selfie. They're very fashionable, they tell me. It's a photograph of Rosetta taken by the Rosetta camera, the navigation camera. I think it's beautiful. You can see the comet up above this, and this is, of course, the power system, the solar cells. So thank you. Thank you to the ESA and NASA for making all this possible, particularly ESA in the Rosetta case. Most of all, thank you for coming along and letting me talk to you about these absolutely wonderful things that happened to me. Thank you.